Hi, we're working on Unit 7 on polynomials. This is our second day, so we're multiplying polynomials. And this is Unit 7, Day 2 for Algebra Honors. So we're partway through our notes. This is our second set of video notes. All right, this method that we're going to use to multiply polynomials together is called the box method. And so what we're going to do is make a box, and we're going to write the terms of one polynomial on a side of the box, and we're going to write the terms of another polynomial on a different side of the box. It doesn't really matter whether you choose to go horizontal with the first binomial or vertical with the first binomial, which you could see if you try it out. So we're going to then multiply anything from one column times anything from one row and multiply other columns and other rows. It's easiest, I think, if I just demonstrate. So let's take a look. You do have an example here that you can look at, but I'm going to go straight to our example one. Okay, so I'm going to say we have 3x and -5. Those are my two terms that I'm putting outside of my grid. Okay, and then my other binomial is 5x plus 2, so I'm going to make this in my vertical locations. All right, now I'm going to take this guy, 5x, and multiply it times anything in the columns that follow. So 5x times 3x is going to be 15x squared. 5x times -5 is going to be -25x. 2 times 3x is going to be 6x, and 2 times -5 is going to be -10. So I'm going to write this all out, and then I'm going to point out something that you can see that happens. Right now, anything inside my grid that I just stuck in there, that's my answer. So I'm going to write it all out. These are all of my terms. 15x squared minus 25x plus 6x minus 10. Okay, all four terms that are in that box are my answer. But of course we want to combine like terms if we can, and so we have -25x that can be combined with 6x. So my final answer is 15x squared minus 19x minus 10. That is my answer. I would get that answer if I used the distributive method or if I used FOIL. Okay, or the box method, clearly. So here's what I want you to see. Check this out. 6x and -25x. See how those are like terms? And they are diagonal to each other? It's not as big of a deal when we just have a 2x2 grid, but when we start multiplying trinomials times trinomials or something like that, it's helpful because you can kind of see your like terms that way. All right, so let's look at our example 2. I have 7p minus 2 times 3p minus 4. So I'm going to put 7p minus 2 up top here. I'm going to put 3p minus 4 here. Again, if I had put 7p minus 2 in my vertical spots and 3p minus 4 in my horizontal, it would still work out, promise. Okay, so check this out. 3p times 7p is 21p squared. 3p times -2 is going to be -6p. -4 times 7p, I have -28p, and then -4 times -2, I have +8. So I took each element here and multiplied it times the numbers above my columns. Each element here times the numbers above my columns. My answer is now in this grid. This time when I write my answer, though, I'm going to show you, remember I said that diagonal trick? Those are my like terms. So I'm going to write my answer as 21p squared. Right, I took care of this box. And then -28p and -6p is -34p. Is it not? It is. And so I'm going to 28 and 6, 29, 30, 31, 32, 33, 34. Yes. And then I just have 8 left over. So that is my final answer. -28 and -6 was -30p, 34 there. Okay, so and again, if I used FOIL or if I used the distributive method, that would be fine. So just keep that in mind. Okay. I now have a binomial times a trinomial. And the way this box is set up, I have to put my x and my 2 here, right? Because that's the place for binomials. and I'm going to put 2x squared plus 3x plus 1 in my trinomial spot up there. Just for reference though, honestly, truly, if I had done my grid like this instead, vertically instead of horizontally, it would totally work, I promise. And so I would just have x plus 2 up here, and then my trinomial terms would come along down here. So I promise you, it doesn't matter. It's going to end up with the same answer. We're just going to do it this way though. I have x times 2x squared is going to be 2x cubed. X times 3x is going to be 3x squared. And x times 1 is just x. 2 times 2x squared is 4x squared. 2 times 3x is 6x, and then 2 times 1 is 2. So this is handy that I can kind of see my like terms just like that. Because when I write my final answer, I'm just going to start writing it in standard form. I'm looking for my highest exponent first. Okay, so 2x cubed is what I see here. And now I have 4x squared plus 3x squared, so that's 7x squared, right? I took care of those, and now 6x plus 1x is 7x, and the only thing I have left is that 2. So that is my final answer. Okay, looking at example 4, again, my binomial terms are going to go here. I have 2x and I have -5, and up top I have -2x squared minus 5x and +4. I didn't mean to jump ahead. I'm going to go back to example 3 and finish example 3. Sorry about that. I got all excited by my grid. Okay, so we solved using the box method. We solved a binomial times a trinomial using the box method. We certainly could have just used the distributive property, okay? Remember, distributive tells me I'm going to take the first term from my binomial in the front and multiply it times everything in that second term. And then I'm going to take my second term in my binomial up front and multiply it times every term in the second expression. If I had a trinomial, I would then have a third term to multiply by everything. So I'm going to set this up by saying that I have x times this trinomial, so x times 2x squared plus 3x plus 1. And I'm going to combine it with, so I'm going to add it to my second term, +2, times that whole trinomial, 2x squared plus 3x plus 1. Okay, so we're just doing the same exact math. You'll even probably see that we end up with all the same terms in here. It's just a slightly different order. And so you just work with what is the most comfortable for you, okay? X times 2x squared is 2x cubed. X times 3x is 3x squared, and x times 1 is just x. Sorry, we did distribute that x everywhere, and here we're going to distribute 2 to everybody. So I have 2 times 2x squared is 4x squared, 2 times 3x is 6x, and 2 times 1 is 2. So now I'm going to combine like terms, and I have 2x cubed all by itself. Since I have so many terms, I'm going to actually kind of slash through when I've used them. 3x squared I can combine with 4x squared and nothing else, because those are my like terms. So I have 3x squareds, and then 4 more x squareds. I have a total of 7x squareds. Okay, and then x and 6x, I have one of them, invisible 1, right? 1 and then 6 more, so now I have 7 x's. I've taken care of my x's, and then I have +2. So cross our fingers that when we look up here, it's the same answer, 2x cubed plus 7x squared plus 7x plus 2. Excellent, all the same. Now I get to look over here at exit 4. Exit 4, listen to me. Example 4. Okay, so I have set up my box for my box method, and so I put my binomial here because that's where I had 2 slots, and I put my trinomial up top. Okay, 2x times -2x squared is -4x squared. 2x times -5x is -10x squared. And you guys need to correct me. If you were in my classroom, you would say, Mrs. Thomas, I think you mean x cubed. 2 times -2 is -4. X times x squared is x cubed. Look at me catching my mistakes. Okay, Negative 5 times negative 2x squared is going to be 10x squared. Negative 5 times negative 5x is 25x, and let's see, 2x times 4 is 8x. Negative 5 times 4 is negative 20. Whew, hope I got that. So let's check it out. I see my like terms. So that's actually these like terms on the diagonals. It's another place that you can help catch the fact that you might have written x squared when you meant to write x cubed. So if it's not matching up, just double check and see if you can figure out why, if you just made a careless error like I just did. Those are like terms, and then these guys are like terms. So now I'm just going to go straight to writing my answer. I have my negative 4x cubed, and then I have 10x squared minus 10x squared. Poof, gone. No x squareds. 25x plus 8x is 33x, and then I have negative 20. So I believe that is my answer. And just for kicks for right now, I am going to use the distributive property to double check. Remember, we can't use FOIL on this because I don't have two binomials. So I can use distributive property though. I'm going to take my first term and multiply it by everybody in the following trinomial. And then I'm going to combine it with my second term times everybody in the following trinomial. So 2x times that whole big guy, negative 2x squared minus 5x plus 4. Right? I'm distributing 2x times everybody over here. I'm going to combine it with, so add 2, negative 5 times that whole trinomial. Negative 5 times negative 2x squared minus 5x plus 4. And now I've got to watch and make sure I don't go off screen for you. Okay, so let's do a whole lot of distributing. 2x. I've got 2x times negative 2x squared is really negative 4x cubed. See me remembering my x's. 2x times negative 5x is negative 10x squared. 2x times 4 is 8x. Plus negative 5 times negative 2 is positive 10 times x squared, so I have 10x squared. Negative 5 times negative 5x is positive 25x, and then negative 5 times positive 4 is negative 20. I'm going to combine like terms, and again, lots of terms here, so I'm going to kind of slash through as I've used each of my terms, okay? Negative 4x cubed, I don't see any other x cubed, so negative 4x cubed by himself. Negative 10x squared and positive 10x squared, poof, gone. 8x and 25x is 33 x's. And then finally, I'm going to subtract 20 because that's what I've got left there. Let's double check and hope. Negative 4x cubed plus 33x minus 20. Hooray! Since we got the same answer, we can feel fairly confident that we must have done it right. Okay. This is our last page. So this is your classwork. So I really do suggest that you try the classwork on your own. You can even pause the video right now and do one problem at a time, or try all of the classwork and then come back, and if you kind of skip to the, skip through the video, you can just quickly check your answers. Okay, try it on your own, careful of your negatives, and again, you can use whichever method works for you. So we are using distributive property, or we are using FOIL, assuming it's just two binomials, or we're using the box. So I may not choose the same method as you, but we should come up with the same answer. So go ahead and pause the video, try some of these, and then come back and check your answer. All right, so I think I'm going to use FOIL for the first one. So remember FOIL, first, outside, inside, last, right? FOIL, first, outside, inside, last, or first, outer, inner, last. So I'm going to do firsts. I have 2x times negative 3x is negative 6x squared. My outer is 2x times 4, so that's positive 8x. My inner is 21x, right? Because negative 7 times negative 3 is positive 21 times x. And then my lasts, negative 7 times 4, that's negative 28. And then I want to combine like terms, so I have negative 6x squared plus 29x minus 28. Just for kicks, I'll do number 2 using the distributive property method. So I'm going to distribute 4x times everything, and then I'm also going to combine it with 5 times everything. Okay, so I'm going to have 4x times the second binomial, and I'm going to combine it with 5 times the second binomial. Okay, first term of the expression and then second term of the expression. Don't lose your negatives. Be super careful with negatives. Now when I use distributive property, I have 8x squared minus 24x. Over here I have plus 10x minus 30, and I'm going to combine those two like terms in there. So I get 8x squared minus 14x minus 30. I'm going to use a box because I can. Okay. I noticed something different about these guys. Notice how this binomial actually has x squared and not just x. Incidentally, it's gonna change where the it might change where my like terms show up. So let's take a look. I'm gonna make a box just like so, and I'm gonna put 8x squared here and negative 1. And then I'm going to put 3x and negative 2. It looks like I get to write small because I made a little box. 3 times 8 is 24. X times x squared is x cubed. Sorry for the tiny writing. 3x times negative 1, I have negative 3x. Negative 2 times 8x squared, I have negative 16x squared. And negative 2 times negative 1 is positive 2. If I make an error here, I guarantee it's because I made that box so small. So look, I normally would look at my diagonals to see where my like terms are, but it's because I had x squared instead of x in one of my binomials. I don't have any like terms inside all that big box, right? So I can see that my answer is 24x cubed. I'm going to go in the order of highest exponent down to the lowest exponent. So I'm going to say negative 16x squared next, minus 3x plus 2. Okay, that really is my answer, 24x cubed minus 16x squared minus 3x plus 2. And you could have done that problem using distributive property or using FOIL also. Okay, so here I think I'm going to use FOIL again. It's kind of arbitrary. I don't know what makes me make my choices, but I'm going to use FOIL again. I will say if I ever have a trinomial that I'm multiplying, I make a box. It's just the easiest way for me. FOIL, I'm going to do my first 2. So 2x squared times 7x, that's 14x cubed. Outer is 2x squared times 1. Inner is negative 6x times 7x. Negative 6x times 7x is negative 42x squared. And then last is negative 6x. Okay, and so if I had done box method here, we actually would have had some diagonal-like terms. That's because I've got 6x as my second term here, just so you know. So just, there are lots of little patterns that you can see as you go through these problems. I want to make sure that this is all in standard form, so I'm going to say that this is 14x cubed minus 40x squared, and then minus 6x. That is my answer. All right, y minus 7, all of that squared. I am going to be super careful, and because I promised I would, I'm going to write it out. Y minus 7 times y minus 7, because I do not want to make a careless error. Okay, watch, it's going to be, I'm going to use FOIL. Y times y is y squared. Outer is negative 7y. Inner is negative 7y, and last is positive 49. My answer is y squared minus 14y plus 49. Okay, if I got all crazy and saw something on a multiple choice test and saw y squared minus 49, or even worse, y squared plus 49, I don't know which one of those is worse. That's not my answer, right? Because I'm missing the middle term. So really be careful. Really be careful. Don't be fooled. This has a middle term. This is going to have a middle term too. Be careful. Let's do this box method style. I learn from my mistakes and make my box a little bigger, not much. 2m minus 5. Well, it's the same thing, so I'm going to have 2m minus 5 going that way too. 2 times 2 is 4. M times m is m squared. 2m times negative 5 is negative 10m. Negative 5 times 2m is negative 10m, and then negative 5 times negative 5 is 25. I have like terms, and so my answer is 4m squared minus 20m plus 25. Okay. All right, I hope you're remembering to pause and try these on your own and come back and check. So this is just more complicated, but not really. I just need to make sure I write down what I want to be doing. I think I'll do this. I'll do this box method style. Since there's so much going on, I'm going to do a big old box this time, though. Okay, because I have multiple variables and stuff like that. Okay, so it's negative 2a plus 3b times negative 2a plus 3b. Negative 2 times negative 2 is positive 4. A times a is a squared. Negative 2a times 3b is going to be negative 6ab. Here, 3b times negative 2a is going to be negative 6. I'm going to write it as ab instead of ba. It's just handier because then I can see my like terms. Right? We like to have things alphabetical because mathematicians are nice and organized. Okay, I have 3b times 3b is 9b squared. So I can see that I have like terms. My answer is 4a squared minus 12ab plus 9b squared. Okay, I know you guys are all curious and you always want to make sure that everything is true no matter what. That's what we think our answer is, right? 4a squared minus 12ab plus 9b squared. If I had done FOIL with this guy, if I had done FOIL with this guy, negative 2a plus 3b times negative 2a plus 3b. Okay, I'm just doing the same problem with FOIL, so you can fast forward through this if you don't want to see. First, I have negative 2a times negative 2a, so I have 4a squared. Outer is negative 2a times 3b, so it's negative 6 times ab. Inner is also going to be negative 6 times ab. Again, I'm writing it in alphabetical order because then I can see my like terms, right? I understand that negative 6ba is probably what you see when you do your inners. 3 times negative 2 is negative 6. B times a is ba, but we know ba is the same as ab, right? Okay, and then my last 3b times 3b is going to be 9b squared. So I have 4a squared minus 12ab plus 9b squared. And boy, do I hope that's the same as what I got before. It is. Awesome. Okay, you're probably starting to see some patterns when you multiply, or rather when you square a binomial, and we will talk about those eventually. But all right, 5k plus 2 all squared. So if I do this using distributive property, you know it actually looks like 5k plus 2 times 5k plus 2. I'm going to do it distributive property even though that's actually not what I typically choose. So that means I take 5k times everything and I combine it with 2 times everything. That's 5k, even though it looks like an x. I'm sure I meant to write k. 5k plus 2. Okay, so I've distributed the first term in my first binomial to the second binomial, and I've distributed my second term in the first binomial to the whole second binomial. So I end up with 25k squared plus 10k, yeah, using distributive property, plus 10k plus 4. And I can combine like terms, and I get 25k squared plus 20k plus 4. Voila. Okay, nearly done. Number 9. Okay, as soon as I have a trinomial, I'm making a box. I'm just making a box. And I'll try to make a big enough box since we all know I tend to not do that. All right, because of the way I made my box, my trinomial is going on top. And my binomial is going on this side. X times x squared is going to be x cubed. 4 times x squared is 4x squared. I've lost my cursor. All right, x times 3x is going to give me 3x squared. And 4 times 3x is 12x there. So I have 4 times negative 6. I don't know why I went out of order. And then x times negative 6 up there. Okay, I can see my pretty little combining like terms diagonals there. So in the proper order, this is going to be x cubed plus 7x squared plus 6x minus 24. That is my final answer. Okay, again on this one, I do have a binomial and I have a trinomial, so I'm going to use the boxes. Just because I keep promising that you can do this vertically, I'm going to do this one vertically. Watch what happens. Ooh, I have no ink. Oh, there it is. Okay. I'm having pen difficulties this time, aren't I? Right, so I still have a 2 by 3 or a 3 by 2, right? So now this time I'm going to put 2v plus 3, and then I'm going to have 4v squared minus 3v minus 6. 4 times 2 is 8, v squared times v is v cubed. 4 times 3 is 12, and then times v squared. Negative 3v times 2v is negative 6v squared. Negative 3v times 3 is negative 9v. Negative 6 times 2v, negative 12v, and then negative 6 times 3 is negative 18. So I still get my nice handy little diagonals to show me my like terms, and my final answer should be 8v cubed plus 6v squared minus 21v minus 18. 8v cubed plus 6v squared plus 21v, nope, I'm sorry, minus 21v minus 18 is my answer. Great, all right, thanks so much for watching.